Good day, everyone. In this experiment, we will discuss the making and curing of concrete test specimens. This laboratory activity is important in construction materials testing because it helps evaluate the strength and quality of concrete used in structures. Concrete is made by combining cement, sand, gravel, and water in proper proportions. In this experiment, a 1:4 mix ratio was used to produce concrete specimens. Proper preparation, molding, compaction, and curing are necessary to ensure accurate and reliable test results. The concrete specimens were placed in cylindrical molds and cured under water for different curing periods to allow hydration and strength development. The activity aims to prepare and cure concrete test specimens for laboratory testing and evaluation. At the end of the experiment, the students shall be able to prepare concrete mixtures using the proper proportion of materials, perform proper molding, tamping, and compaction of concrete specimens, understand the importance of curing in concrete strength development, apply laboratory testing procedures, and interpret concrete test results. The experiment involved the preparation of concrete specimens using a 1:4 mixture of cement, sand, and gravel with a water-cement ratio ranging from 40% to 60%. The materials were thoroughly mixed on a mixing plate until a workable and uniform concrete mixture was achieved. The fresh concrete was then placed into cylindrical molds in 3 equal layers. Each layer was tamped 25 times using a tamping rod to eliminate air voids and ensure proper compaction. Proper compaction is important because trapped air inside the concrete can reduce its strength and durability. After filling the molds, the top surfaces were leveled and finished using a trowel or tamping rod. The curing process was performed by immersing the specimens in water for 7, 14, and 21 days. Curing is essential because it allows continuous hydration of cement, which increases the strength and durability of concrete over time. This experiment demonstrated the importance of proper mixing, molding, compaction, and curing procedures in producing quality concrete specimens for testing. The following materials and equipment were used in the experiment: weighing scale, cylindrical molds, brush and grease, measuring tape or ruler, pails, sampling and mixing plate, scoop, shovel, tamping rod, trowel, potable water. A. Preparation of samples. First, the cement, sand, and gravel were prepared using a 1:4 proportion by weight. The required amount of water was then measured based on the desired water-cement ratio. Next, the materials were mixed thoroughly on the mixing plate using shovels. Water was gradually added while mixing until a workable concrete consistency was achieved. B. Preparation of molds. Before molding, the cylindrical molds were cleaned and coated with grease to prevent the concrete from sticking. The molds were placed on a level and stable surface. Each mold was filled with concrete in 3 equal layers. Every layer was tamped 25 times using a tamping rod to ensure proper consolidation and remove trapped air. After the final layer, the top surface of the concrete was leveled and finished using a trowel. C. Curing of specimens. After molding, the concrete specimens were allowed to set for 24 to 48 hours. The specimens were then immersed in water for curing. 4 specimens were cured for 7 days, another 4 for 14 days, and the remaining 4 for 21 days. The curing process allowed the concrete to continuously gain strength through cement hydration. The experiment successfully demonstrated the proper preparation and curing of concrete test specimens using a 1:4 mix ratio of cement, sand, and gravel with a water-cement ratio of 0.45. The concrete was properly mixed, placed into cylindrical molds in 3 layers, and tamped to achieve proper compaction and reduce air voids. The specimens were then cured under water for different curing periods to improve strength development. Although the standard 7, 14, and 28-day testing schedule was not fully completed due to time constraints and unexpected delays, the experiment still highlighted the importance of proper specimen preparation and curing in producing quality concrete for construction applications. Thank you for watching.